drop of water falls into a still pond in extreme slow motion, and the ripple becomes a digital grid of glowing blue nodes. A macro shot of a human eye reflecting a colorful nebula fills the frame. High contrast lighting reveals objects appearing in two states at once, ghosting between realities. The floor beneath your feet feels solid, and the air you breathe feels empty. The stars above seem fixed in their ancient positions. For as long as humans have looked at the world, we have trusted this stability. We built our cities and our laws on the belief that reality is a dependable, predictable machine. When you zoom in past cells and molecules into the atom, the world evaporates. In its place is a ghostly realm of shadows and possibilities where things happen because they might. Today, we acknowledge a shift in the human story and celebrate a frontier that changed everything. In the early 1900s, physics seemed to finish science until phenomena at small scales made the math break. Max Planck discovered that energy moves in tiny, discrete packets he called quanta. That small crack in understanding opened the flood of a new, strange physics. Heisenberg showed you can never fully know a particle's position and momentum at the same time. To observe the world was to disturb it. The observer became a creator. This realization sparked conflict as giants like Einstein resisted a universe ruled by chance. Decades of experiments delivered a verdict. The subatomic world obeys beautiful, terrifying illogic. This spooky reality is why you can see these images. The first quantum revolution built our modern world. We were sailors using stars to navigate without knowing what a star actually was. Now we are crossing into a second revolution where we begin to touch quantum effects directly. Imagine a machine that doesn't just work faster, but works differently. A quantum computer. A classical computer is a librarian reading books one by one. A quantum computer reads every book at once. This power could let us design levitating materials, carbon-sucking chemicals, and bespoke medicines. But a heavy shadow looms. Quantum processors could shatter modern encryption in seconds. Nations race in silence to rewrite the world's locks before a quantum skeleton key emerges. These consequences are not merely technical, but deeply emotional for how we see ourselves. For centuries, we felt like isolated specks in a vast vacuum, but entanglement tells a different story. Change one particle, and its partner reacts instantly, as if distance is irrelevant. If the smallest parts of us are connected to the cosmos, isolation becomes an illusion. We live in a participatory universe where observation ripples through a web we are only beginning to map. As we look to the future, the takeaway is profound humility about our place in a participatory cosmos. We spent millennia thinking we mastered a clockwork world, and now we realize we are participants in an interconnected reality.